Hi, hello guys, welcome back to Tech World. This is another video where we are going to know about the evolution of digital IC technology, which is related to digital designing and computer organization concept in engineering. We are going to explore about the digital ICs which have gradually increased in the transistor and level of size occupied in the computer motherboard. Into the captivating story of how the digital ICs technology have revolutionized in the world of electronics from the foundation of Moore's law and progressing ICs architecture. This video will guide you towards the remarkable advancements that have shaped the digital ICs landscape. Moving further into the Moore's law and exponential growth of technology transistors, where in 1965 Ron Morse predicted the number of transistors in a chip will double every 2 years, which did happen. In 1970s, where the transistor count of ICs rapidly doubled and enabled the more complexity problems, power efficient electronics. Nowadays, which we are going to use, have the transistor counts have reached billions and trillions, where the powering and modeling digital devices. Going further, now the shift of analogous to the digital circuits, which have made major and tragic dependent on the circuits of digitals. Here, there are analogous circuits, electric signals that can be taken in any value within a range, where the digital discrete electronic signals that can only take only 1 and 0 as these two values, which makes an task easier. Advantages of digital: more robust, earlier to process, and less subject to noise and interference, enabling a new application and digital circuit powering modern computers, smarter and wider in range of digital devices. Coming to the process of digital ICs architecture from an bipolar to CMOS. The bipolar, which has the older technology in earlier digital ICs, used in transistor technology, which was powered by a huge but was faster. But coming to the MOSFET transistors, which is complementary metal oxide semiconductor, or as CMOS technology, enables the smaller and most powerful, efficient digital ICs. CMOS dominating. CMOS has dominated the bipolar transistors and leading in the field, where the CMOS becomes an dominated technology for an digital IC, powering everything for an microprocessors in a memory chips. Going further, naming patterns in a digital ICs. They are named behalf of their processor size, transistors used, and the scaling trends and feature size, die size, processor nodes, which we are going to say as the size of the chip. The physical size of an integrated circuitry chip measures in a square millimeter. As I said, the measurement is in naming of chip involves. The feature of the size. The smaller possible size of a transistor, other components on the chip measures in a nanometer. The processor node, technology generations named after the 14 nanometers, 10 nanometer, and 7 nanometers, and coming 5 nanometers, where the nodes which are defining the number of size of the patterns and the transistors in it, which I said in the feature size. Scaling trends. The transistor counts and performance have increased exponentially as the feature size have decreased, where the trends have exponentially have increased, but the size has decreased gradually. Going further, here you can see an images from the ancient period to the overall time, where the transistors have changed from the older generation to the newer generation, which we can see nowadays in the center, and probably in the last two side. This last one is the oldest, and the first two are the oldest. Going further, the impact of minimizing, the impact of miniaturization. Power efficient and smaller transistors used in less powerful and enabling the longer battery life for a lower energy consumption. Speed and performance. Shorter signals path and high transistor counts allows for a faster processing speed. Cost and scalability. The smaller feature size enables the more chips per wafer, reducing the manufacturing cost. Coming to the challenges and innovations and advantages digital ICs manufacturing. Nowadays, the quantum effectives, heat dispersal, and prescribed manufacturing and novel architecture, which are the four functions which we are going to majorly concentrate in the IC field where manufacturing it. So quantum effects and transistor shaking and quantum mechanics phenomena becomes a more prominent requirement in a new design statistics where or strategies. We are coming to the heat disposition. Increases the power density of an advanced chip, creating a significant thermal management challenges. Pres- prescription manufacturing. Prescribed manufacturing fabricates the features at a nanoscale requirement, advancing in the generic and effective in controlling the technology. Novel architecture. Innovation 3D chips, stacking, and alternatives, transistors designed for being an export to and continuous scaling. Going further, of ICs in the future trends and technologies will belong to silicon, quantum computing, and neuromorphing chip. Exploring the alternative semiconductor materials like an helium nitride and carbon nanotube to overcome the silicon's limitations, the quantum computing, the hardness of the unique propose, pre- properties of the quantum mechanics to develop radically new computing architecture, neuromorphic chip, where the designing of the chip im- uh, inspired by a human brain and enabling the more effective AI and machine learning applications nowadays. Going further, the upcoming generation, which is the next generation digital IC, the 5 nanometers, and it has a future size pushed to an borders of a miniaturized to create an even powerful and effective digital IC where 1T, where the transition count, the integrated trillions of transistors on the and single chip, enabling the unprescribed related computerization capability in this computer, and 50x performance boost, achieving an exponential increase of an processor speed and energy effectively throughout the ongoing innovation. Totally, the 5 nanometer feature which we are going to get in the next upcoming generation chips are going to be an innovative and more exploration for us to do the jobs more easily and more faster. I thank you all for listening my video for this patiently in